Good evening, physics enthusiasts. In this video, we will be deriving formulas that we will use later on in solving problems involving projectile motion. So, let's begin with case 1 of projectile motion. Pasensya na nga pala kayo kasi naubos na ako ng marker kaya ballpen na lang muna tsaka bond paper ang gagamitin ko, alright? So let's begin with case 1 of projectile motion for objects thrown horizontally from a certain height. Say for example, you have here a ball and it's given a push horizontally. Alright? So of course it will move horizontally. Okay? So let this be the initial velocity given to the object. But first, let me ask you, what is the x component of this velocity? Very good. Since ito ay horizontally, automatically, yung binigay na initial velocity, siya na mismo yung Vx. Alright? But how about our Vx initial? Pwede mo sabihin na ganon. Vx initial. Alright? But how about the y component of this velocity initially? So as you can see in the diagram, it has no y component. Therefore, the initial velocity along y is 0. So how does this object travel? Will it go straight horizontally? Of course, the answer is no. It will not move horizontally all throughout because gravity pulls it to the ground. Alright? As such, it will move in a curved path. Okay? Say for example, parang ganito. Okay? Until it hits the ground. Alright? So, as the projectile moves through space, the horizontal velocity given remains unchanged. That's one thing you have to take note about projectile motion. Okay, so we can treat them separately, or we can analyze the vertical and the horizontal motion separately. So in this case, Vx remains constant. Vx is constant or does not change all throughout. Say for example, ang binigay na initial velocity ay 5 meter per second. All throughout the path of the projectile, the horizontal component of the velocity will be equal to 5 meter per second. On the other hand, if we analyze the vertical component of the velocity, initially it is 0. But since the gravity pulls it downward, it will increase at every instant. So say for example, at this point, ganyan siya, and then at this point, medyo mas malaki na. And before it hits the ground, syempre mas malaki na yung kanyang vertical component ng velocity. Alright? So in other words, Vy is not constant because of the pull of gravity. Alright? So, sinabi natin, for projectile motion, the horizontal motion does not affect the vertical motion, and vice versa. The vertical motion does not affect the horizontal motion. As such, we will be having separate equations for the horizontal motion and for the vertical motion. So let's take this for example. Along the horizontal, we have a constant speed or velocity, alright, in straight path. Alright, so therefore, what kind of motion is present along the horizontal? Very good. That is along the horizontal, we have what we call uniform motion. Constant ang speed. Okay, so all throughout. So therefore, since we have a uniform motion, the applicable formula to compute for the horizontal velocity is equal to Vx is equal to dx over time. Of course, the horizontal velocity distance dx rather, ito yon. So mula dito sa kung saan siya ni-release hanggang dito kung saan siya nag-land. So that is dx. Okay, so happen that dx is given a special name. So it's called range, r, represented by capital letter R. Similarly, of course, the object or the ball moves vertically, or it covers a vertical distance, which we call as dy, or simply height, the height. Okay, so therefore we can determine, so this is one formula if you are solving for the horizontal component. But if it's already given, no need to solve for the horizontal component. Now, from this equation, we can compute for the horizontal distance. So manipulating this equation, we have Vx times t. And since dx is equal to range, we can rewrite this as range is equal to Vx times t. So this is our equation in order to solve the horizontal distance covered of a projectile in case 1. How about the vertical distance? We can use along the vertical or say for example along y, ito ay along x component or horizontal. Along y, there is a constant what? Constant acceleration. So UAM ang meron sa y component. Specifically, in this case, we have a free fall. So in other words, we are saying here that the ball is moving horizontally at a constant speed, and at the same time it is falling with constant acceleration vertically. So therefore, the formula for free fall applies. So H is equal to VIT plus 1/2 GT squared. But the velocity initial along y, since this is dy, h is equal to dy, so ibig sabihin the vi should also be along y. V initial y, as you can see here, is 0. Okay, so therefore this becomes 0, and the equation is reduced to h is equal to 1/2 GT squared. So ito ang formula natin. Okay? So ganyan lang kasimple ang case 1 ng projectile motion. Dalawang equation lang yung tatandaan mo. R, this is for the range or the horizontal distance covered by a projectile in case 1, and the vertical distance or the height covered by the object in case 1 of projectile motion. Now let's proceed to case 2 of projectile motion, wherein in this case, the object is projected at a certain angle. Say for example, the ball is projected at a certain angle, theta, from the horizontal. So this is the horizontal. Of course, the object will move in a parabolic path before it goes back to the same level. Okay, and in doing so, it will cover a horizontal distance known as range, and of course it will reach a certain maximum height or maximum vertical distance. Okay, now let's take a look. Again, may I remind you that in analyzing projectile motion, you have to analyze separately the horizontal and the vertical motion of the object. So in this case, since we are given here the initial velocity, Vi, of course it has x component, Vx, and y component, Vy. Sorry, hindi na pumapantay yung drawing ko. Okay? So, basta meron siyang Vx and Vy. So, again, the same rule applies. For projectile motion, it's a combination of uniform motion along the horizontal and uniformly accelerated motion along the vertical. Alright? Okay, so along the horizontal or along the x, Vx is constant, does not change. Okay, so we have in this case a uniform motion. So, ibig sabihin, all throughout, the value of Vx is the same. What happens when the object is at the highest point? Ganun pa din ang value ng Vx. All throughout. And even before it hits the ground, Vx is the same. Say for example, ang nakuha mong Vx halimbawa ay 7.2 all throughout yung x component ng velocity ng object or ng projectile. Ang pinagkaiba lang ngayon pala ay mahaba na yung time of flight niya. Kanina sa case 1, parang ito yon, di ba? Yan. Parang yan lang yung time needed. Okay? In this case, dalawa na. So, kaya you will also consider the time to go up, and you must take note that it is the same time to go down to the same level. So, T up is equal to T down. Kaya, yung total time of flight is represented as 2 times, o pwede mo itong sabihin na T. Alright? So, twice kasi meron kang T up plus T down. And since they are the same, so you have 2T as the total time of flight of a projectile. Alright? So, next, since meron itong initial velocity ay merong x and y component, okay, establish muna natin. The v initial x is equal to v initial cosine theta. And the v initial y, or the initial velocity along y, is vi sine theta. So, kung naalala nyo pa yung topic natin sa vectors, ganito yon, di ba? Therefore, the horizontal distance can be computed using Vx times, instead of t na maliit, I will use total time, yung malaki. Okay, since we have t up and t down. So again, emphasize ko lang, t up is equal to t down. So for example, the object took 3 seconds to go up to the highest point. It will also take 3 seconds to go down to the same level. Alright? So therefore, from here, kung kukunin natin yung x component mula dito, so this becomes r is equal to v initial cosine theta times the time. So this becomes our formula for the range for case 2. Okay. However, as the object moves up, what happens to the vertical velocity? So, nababawasan. And at the highest point, in here, Vy is 0. Merong Vx yung object, pero ang kanyang Vy is 0. That's why the object stopped from going up any further. Hindi na siya umangat pa. Pero nag-move pa din siya horizontally. So ibig sabihin meron siyang horizontal component ng velocity. Kasi kung wala, dapat magpo-fall na lang siya dito, 'di ba? Eh meron pa din siyang natitirang Vx kahit na 0 yung Vy. So kaya nag-move pa siya on this part. But since for uniformly accelerated motion, our acceleration is equal to negative g. So negative Vi sine theta will be equal to negative g times t. So magka-cancel out na yung negative sign, such that our if we solve for time, for example, solve for time, negative g over negative g, then t is equal to positive Vi sine theta over g. Alright? So remember that the smaller t represents either t up or t down. Okay? So in this case, it's t up. For example, kung ito ay consider natin na t up, kaya lang sabi natin t up is equal to t down. So ibig sabihin, yung total time is simply twice nung t up. Okay? So ibig sabihin, twice of Vi sine theta over g, yung ating total time. Okay? So as such, if we substitute this to our formula of the range, we will have an alternative formula for range. So substituting t to r, we have r is equal to Vi cosine theta times ito yung t natin, yung twice of the smaller t, which is equal to times 2 Vi sine theta divided by g. Simplifying further, we will have we will have Vi squared times 2 cosine theta sine theta all over g. In trigonometry, there is an identity equal to 2 times cosine theta sine theta. And what is that? Very good. 2 cosine theta sine theta is equal to sine of 2 theta. Okay, or sine of the double angle formula. Okay, so this becomes Vi squared sine of 2 theta divided by g is equal to r. Okay, So, ayusin ko lang ha, itong part na to. Hindi na kasi makita eh. So, ito yan. R is equal to VI squared sine of twice the angle over G. Okay, so for case 2, in solving the range for case 2, you can use either this equation, R is equal to VI times the cosine of the angle times the total time, okay, which is just twice the time up or twice the time going down, okay, or equal to 2 VI sine theta over G. Or you can use the equation R is equal to VI squared sine of twice the angle over G. Now, what about the height? In order to solve or to derive the equation for the maximum height attained by the object, let's consider the kinematic equation H or dy is equal to V final plus V initial over 2 times the time, smaller t. Alright? So since we're talking about the vertical distance, so this is vertical distance, dy. Siyempre, yung mag-create ng dy ay yung kanyang velocity along y. V final y plus V initial y over 2 times the time. Okay? But what is the as the object moves up, what is the final velocity along y? Vy is 0 at the highest point. Okay? Since V final y is 0 at the highest point, then the equation becomes H is equal to 0 plus V initial y. So, ito ang ating V initial y, Vi sine theta. So, we will put Vi sine theta over 2 times t. But what is t? T up or also equal to t down is equal to Vi sine theta over G. So if we substitute that to this equation, so I will have Vi sine theta over G. Okay? So wala na to, 0 na yan. So ang minumultiply mo na lang, Vi sine theta times Vi sine theta divided by 2 times G. So we will have H is equal to Vi sine theta times Vi sine theta. Siyempre, the answer will be Vi squared sine theta squared all over 2G. So this is another formula for the height, or this will be the formula for determining the maximum height attained by the object. Okay? So or in some cases this is H max is equal to Vi squared sine squared theta all over 2G. So ito tsaka itong equation na to pareho lang. Okay? So kaya lang pagkagagamit kayo sa calcu, yung sine squared theta is actually equal to this. Sine theta mo muna siya bago mo i-square. Okay? So ganun ang mangyayari dyan. Alright? So again, ito yung mga tatandaan yung formula, yung mga nakabilog. the total time of flight is equal to twice the time to go up or the time to go down. Okay? T up is equal to T down. So, twice of that, or pag pinag-add mo sila, you will have the total time of flight. Okay? Yung total time na siya. Okay. Vix is equal to Vi cosine theta. Viy is Vi sine theta. From that, you can calculate the range equal to Vi cosine theta times the total time of flight. You can use this formula or the alternate formula for range, which is equal to Vi squared sine 2 theta over G. And syempre, ito yung galing sa derivation natin yan, kung paano nakuha yun sa time. For the maximum height or for the height, we can use H is equal to Vi squared sine squared theta, ito yon, over 2G. Or similar lang siya dito sa Vi squared times the quantity sine theta squared over 2G. Same lang yan. So those are the formulas for case 2 of the projectile. On our next session, we will be trying to solve problems involving projectile motion using these equations. Okay, so I hope you learned something. Goodbye and thank you. Bye.